Dear students, in this example, it says that why do the electric field lines never cross each other? Now, this is a very fundamental question, and we already know that the electric lines of forces, if they are like this, so we can always come to a conclusion that they can get very close to each other, and wherever the density of the electric field lines is more, there the electric field strength will be higher. So now, because they're talking about crossing each other, so let's take a case in which they're crossing each other and let's disapprove of it. And before that, let's know how do we calculate the electric field, the direction of the electric field uh, using the lines of forces. For example, at this point, if you want to find the electric field, it will be along the tangent to this line. So this will be the electric field. And if the density of the lines is more, you can say the magnitude of this electric field is more. Now take the case which is not happening. For example, as the question says, why don't they cross? Assume that they cross each other. For example, two lines of forces have crossed each other. So at this point of intersection, you can always state that you can draw two tangents to the two lines, and here you can directly say that we cannot at one point. Obviously, the electric field has to be in one direction because it's a vector. So it becomes paradoxical that there are at one point there are two electric fields, but in an electric field at one point the electric field has to be only in one direction. That means if you put a test charge over here q, so it will experience a force because of the electric field. So this force has to be in one direction. So for example, if it experiences a force QE1 and a force QE2, so because it's q naught and it's a very small test charge, so these are the two forces. So the resultant force will be in this direction. So that means if the resultant force is in this direction, then the resultant electric field direction would be in this direction. But then this disapproves of the fact that these are intersecting, and we have obtained two directions of the electric lines of forces. So this is the reason how we can explain that electric field lines never cross each other, because at that point of intersection you'll have two different directions of electric field, which is practically not possible. That will be the answer to our problem.